Internet of Things makes our cars driverless, our homes connected, our cities smart, and factories run seamlessly. Artificial intelligence combined with IoT data is where the business value is created. Imagine yourself in the driverless world. I will teach you to pivot your career and innovate in your business using IoT, AI, and autonomous vehicles. Let's begin your journey with me today. Hello, I'm Sudha Jamthe. I attended Stanford Energy Week today. All of the poster sessions were focused on some kind of data-driven analytics and prediction using machine learning. I'm thinking about V2G and trying to validate what is the real state of research out there. There was energy demand prediction for appliances. So each refrigerator is treated like a solid-state device and then modeled to predict how much energy it will consume. There was data-driven urban analytics based on what other buildings are in their proximity. Next, I bring you neural network for real-time energy management of buildings. Rebecca Wolcoff is the machine learning engineer at Enel X. Enel X is the green tech unit of Enel, the Italian utility based in Rome. I'm very excited because Enel's eMotorworks, another unit, partnered with EO in UK and tested V2G or vehicle to grid batteries that I wrote about in Axios. So Rebecca is going to tell about how her team does behind the meter energy storage using artificial intelligence machine learning algorithms.
We provide an energy storage system that is often paired with solar and can save customers energy and money on their daily bill.
So tell me what you were talking about, right? That anything that is metered, you love the data and you help your customers.
So what our group does is we take that metered data and we run it through our machine learning algorithms, and we want as many meters as possible. So we want the building data, we want the solar data. We'll run it through our neural net. It'll learn what that looks like and then produce a forecast for us for the next 24 or 48 hours. And we don't just predict that load, we actually stochastically predict that. So we'll get 3 or 4 different predictions of each meter load, and then we'll feed that into our optimization engine. And our optimization engine takes that stochastic data, figures out, okay, these are the boundaries of where the load might be, what is the optimum thing to do with this battery right now and for the next 24 hours. And it'll run with that for the next 15 minutes, and 15 minutes later, new data comes in, it adjusts, and it does it again forever, which saves our customers lots of good money on their bill and lots of energy.
Your customers are commercial buildings?
Commercial and industrial buildings.
So you operate at the edge of the building?
Yes, we operate at the edge of the building. We also have some customers who are microgrids and are not connected to the grid either sometimes or all the time, so we can do either.
So tell me a little bit about the model you developed.
If you have 2 buildings, then you're going to have 2 different load forecasts and scenarios for each load forecast, and those create, more. So if you have three scenarios on one building, 3 scenarios on another building, that's 3 forecasts for each. Now you have 9 scenarios that you're optimizing for, and you want as much data as possible, because the more granular you get, the better the machine learning algorithm can do in predicting that load data. And so you could even do, let's say you have 2 buildings that are, miles apart. You want the weather at each site. If you're combining those 2 loads, you can't get the data as granularly.
So what you actually offer as a prediction is finally helping your customer decide when to utilize the demand response for the building.
So we can offer that information, and some of our customers do just do demand response and that's it.
Yep.
But our customers with batteries, we automatically use that information in our batteries to use the batteries for the optimum charging or discharging.
I'm curious because I teach autonomous vehicle business, so I need to go back to the business angle. So is your customer paying you on saving on the batteries?
Yeah, so usually we'll have some sort of joint agreement where they can either own the batteries outright and then get all the money from our services,
Yep.
Or We have a dual agreement where we both pay for part of the battery and then each earn some of the savings. Usually it's like a 2 to 3 year recovery of savings. And they'll earn a little money and we'll earn a little money, but it is based solely off of our performance. So the better we perform, the better we can optimize and predict these loads, the more money we're going to save for both our customer and ourselves.
So what is your biggest challenge in keeping this inference model up to date and accurate?
I think one of the biggest challenges is having more meters, because when we only have one meter for solar and a building, you can't, and EVs, right?
Yeah.
How do you figure out what's belonging to what? That's really a much harder problem to learn machine learning wise than if you had EVs, battery, building, solar, all metered separately. So that's one challenge. One of the other, I think, big challenges is a lot of people in our space are saying, hey, look, we could optimize battery use, which we can, but it's a different problem saying that, look, if you did all of these things, apps using the perfect prediction, right, we could get this much savings. It's a very different problem in real time to say, okay, how do we optimize with only this information right now, not knowing what the future may look like. So I think trying to educate people on that difference is very key, because there's a subtle difference, but it makes a huge difference in what savings you can recover.
That's fantastic.
Yeah.
So as buildings become more and more connected with more connected devices in them,
Yeah.
it will only help you with more data feeds, right? Because think of everything as another smart metering point.
Yeah, it will only help improve efficiency, improve savings. There is a limit to how much we can save, but the more we're not anywhere near that limit. And the more you collect that data, the closer to that peak efficiency we can get.
That's fantastic.
Yeah.
Thank you so much for talking to me.
No
I really
problem.
appreciate it. I'm very happy at what I saw today.